Let us consider this problem based on the conditional probability. Here, the probability is straight away given, that is, probability of A is 9 by 20. Probability of B is 8 by 15. But they have given probability of A union B, that is equal to 47 by 60. And they asked to find the conditional probability of the following, right? See, basically we need A intersection B, but what they have given A union B. So the first thing you have to find out is A intersection B. Let us find out, that is probability of A intersection B. That is what one required in the determination of conditional probability. So let us find out A intersection B. So probability of A intersection B, we know probability according to the property P of A plus probability of B, and then minus, of course, this is union, okay? So probability of A union B is equal to probability of A plus probability of B, and subtract probability of A intersection B. In fact, we need this, okay? Now we can take this probability of A intersection B is equal to, that is probability of, you can bring this, and the probability of A union B should go there, is it not? So probability of A plus probability of B, and then minus probability of A union B. Therefore, what is probability of A? It is given 9 by 20. What is probability of B? Probability of B is given as 8 by 15. Okay. Then probability of A union B, subtract, that is A union B is how much? 47 by 60. So 47 by 60, right? Now we need to find out the LCM for this. So the LCM is 60, okay? Now how many times? 3 times, so 27, plus here 4 times 32 minus 47. So that is equal to, that is 7 plus 2, 9, 3 plus 2, 5, minus 47 divided by 60. So that is equal to 9 minus 7, 2, 5 minus 4, 1. So 12 by 60, is it not? So the probability of A intersection B is 1 by 5. So once you have found out probability of A intersection B, just apply the formula and you can get the answers. Okay. Now let us take up the first one. What is the first form equation? Question: probability of, conditional probability of A such that B has already occurred. So what is the formula you had to apply? That is probability of A intersection B, and the probability of the event that has already occurred should be brought to the numerator. So probability of B. Okay. Now substitute probability of A intersection is 1 by 5, and the probability of B, where is probability of B? It is given. So the probability of B is 8 by 15. So 8 by 15. So the answer is 1 by 5 reciprocate 15 by 8. So it means 3 by 8. So likewise we had to find out. Okay, can you do this? Right. And similarly, probability of the second one, the conditional probability of B such that A has already occurred. Okay, so second one, probability of B such that A has already occurred. How to write down the formula? That is probability of the same thing, that is A intersection B divided by probability of A, that is equal to, now 1 by 15 divided by probability of A is 9 by 20, is it not? So you can introduce this 9 by 20. Okay, so therefore 1 by 15 into 20 by 9. So it means 3 times and this is 4 times. So 4 by 27. So that is the second answer. Okay. Is it clear? I'm sorry, that is instead of putting 1 by 5, I have taken 1 by 15. Please correct this. 1 by 5. 1 by 5. So it means 4 times and 4 by 9 is the answer. Right? Okay. So let us move to the next problem. That is probability of A dash such that B has already occurred. So let us consider this problem. Probability of A dash such that B has already occurred. So first of all we need to find out probability of A. We have got the formula for, according to the property A dash B, A dash such that B has already occurred is given by B of A slash B. It means 1 minus, this we have already found out, so 3 by 8. So that is equal to 8 minus 3 by 8, that is 5 by 8. So apply the property. Okay, and similarly we need to find out the next one. Okay, so what is the last problem? That is probability of B dash and A dash. Okay, so probability of B dash and A dash. Take down probability of B dash such that A dash has already occurred. Okay, so for which we should already know the A dash. So therefore it is given as probability of, that is A union B whole dash divided by 1 minus probability of A. So this is the formula, straight formula you can use here. Okay, and therefore it is equal to, and probability of A union B whole dash is nothing but 1 minus probability of A union B, because we already know probability of A union B plus and its complement, that is probability of A union B whole dash is equal to 1. So based on that we can arrive at this. So similarly probability divided by 1 minus probability of A. Now just a substitute. So 1 minus probability of A union B, that is 47 divided by 60. So how to find out probability of A union B? We know the formula of set theory, based on that we can arrive at whole divided by 1 minus and 9 by 20. So that is equal to 13 divided by 60. Is it not 60? Minus 47, 13 divided by 60, whole divided by 20 means 11 divided by 20. So therefore 13 by 60 into 20 by 11. So it means 3 times. So 13 by 33 is the answer. Are you able to understand this? You got already this formula, that is how to find out, probably that is you may be asking this one, how to find out this. We have got the standard formula, P of A union B is equal to P of A plus P of B, probability of B, minus P of A intersection B. So based on that you can proceed. Okay.